Hello everybody, I am Ben from Team Panic, and today we're going to be doing a video that you guys have requested. This is an overview of the Hardox Beetle that I designed to fight my Melty Brain that didn't end up doing that and instead went in the Beetleweight Rumble at Havoc 3. So you guys wanted to know a little bit more about this, so I thought what I would do is kind of run through the design process of this thing with you, and then we'll go into a little bit of an overview of the actual robot itself and what's inside it. Realistically, it's a pretty simple, straightforward build. So before we get into the nitty-gritty of the design details and talk about why I've got Annie here, I should also point out I do actually have a whole second chassis here. I was originally intending to have two of these built, but I didn't actually end up getting two of them built just because of time constraints going into Hybrid World 3. I literally welded these up the weekend before this happened, so I didn't have a whole lot of time, especially considering that at the time Annie was still in pieces and the Melty Brain was still in the test chassis. So I had a lot of stuff I had to do in the week leading up to the event, and something had to give, which in this case was this guy. However, these chassis are actually fairly similar in the fact that the sides, bottom, and back are all exactly the same. The only difference is the front, and that is actually one of the design considerations that I wanted to get into. Because I knew going into this, thanks to Annie Are You OK, that 10mm thick HDPE, which is what I run currently as Annie's front armor, is totally fine for beetle weights. That is more than enough, and most beetle weights cannot get through 10mm thick HDPE. So this chassis was designed to have a 10mm HDPE sheet bolted to the front of it. These two bolts here are M8 bolts, which I knew weren't going to break in a beetle weight because that's what Annie's weapon runs, and yeah, Annie dishes out some big hits, and all of that force has to go through this weapon bolt. It's been totally fine this entire time. So two M8 bolts holding on a 10mm sheet of HDPE was the design intention for the armor on the front of this one. The one that I ended up building, which to me is more interesting, is actually 5mm thick Hardox. It is a slab of Hardox out the front there. The rest of the chassis and this front plate is all 3mm, but this particular one has 5mm thick Hardox on the front of it. There is no way anything ever gets through this. I also decided to build this one because it is a much worse case scenario than the HDPE. HDPE survives so well as robot armor because it nicks out. You can see on Annie, there's a whole bunch of nicks and cuts and scratches and chips gouged out of her front plate. All of that is energy lost from the impact. It's all energy that's dissipated by ripping and tearing at the plastic. Whereas a weapon striking a 5mm thick Hardox plate is not going to do that. The energy is going into this and back into the weapon, and that's it. There is not going to be that much dig and tear out and cut out of this type of system. So, why a wedge? Why the drive system? What is the drive system? All of that kind of stuff. So first and foremost, I knew I wanted this to be the worst case scenario. So I knew I wanted to make the most use of the weight to make something bulletproof. I also knew that welding up a chassis, the chassis were going to be quite heavy going through. So I knew I wasn't going to have weight for a weapon, but also weapons add a lot of complexity and they just add more things that can break. So immediately the answer was going to be a welded wedge like this. The next thing is, once you've eliminated all of the design stresses in the weapon, you need to look at the design stresses for the rest of the robot. So Annie runs around on gear motors, on brushed gear motors that have a 4mm output shaft, and then there is a hex coupler in here that runs the wheels. So there it is. That is the hex coupler that drives the wheels, and that is just grub screwed and screwed onto a D shaft inside there. And that D shaft is from one of these, although this is not quite the same thing because this one's a brushless converted version, but the ones in Annie are just a brushed version of this. This is a 25mm gearbox with a 4mm output shaft with a D on that. Also, I will point out that this gearbox and brushed motor setup, or this gearbox, the output of it is just run through a little bushing at the front here. There is no bearings or anything in this, so it is not uncommon for these gearboxes to break when a robot gets hit, because a lot of shock load gets pushed kind of tangentially or off axis on these output shafts, and a whole lot of stuff in here breaks. So I wanted to beef up the gearbox and the drive system for this, because this is a weak point in these in-combat robots. It's been a weak point in Annie in the past, and you need to keep replacing gears or gear motors in Annie, or I do, to keep her running all the time. So the way I've fixed that problem in this is with a different system. So we have a brushless motor in here that has a small output gear, and then we have a bigger output gear on the wheel, and then the wheel itself is on a 5mm dead shaft. At the moment, these are not hardened steel. Ideally, they'd be a hardened steel dead shaft, and the dead shaft is actually just a 5mm bolt, which we'll get to in a minute. What that means, though, is that we have more metal in the shaft that holds the wheel on, and we also actually have proper bearings in here so that the bearings aren't going to break in hits and different things and bits and pieces like that. These bearings I trust more than the tiny little bushing that is in those brushed motors. Now, I might be wrong on that, but and the bearings are actually weaker than those bushings, but I have seen those bushings come out of those gear motors a number of times. So even if the bushing itself isn't a weak point, how that bushing is mounted, this little bit here, how that's mounted into the gearbox is a weak point. And when it goes, the whole gearbox is dead, essentially. So yes, the M5 bolt goes through a 5mm hole in the chassis, and then you can see we've got a big hole here, which is where our brushless motor sticks out. The reason I went with brushless motors was to get a little bit more speed on the thing, and also because this is semi-YOLO drive, essentially. It's a single stage gearbox off of a decent speed, but not like crazy fast brushless motor. We'll get them out in a second. They are 2826s and 1200 kV from memory, but we'll have a look at those in a second. And also, I will say, we'll get all of the electronics out of here so that we can start having a bit more of a look. We're just running Afro, 30 amp Afro ESCs. There's no real reason for that. It's mostly just what I had on hand at the time. Any brushless ESC that can do reversible for driving would be totally fine in here. These are just what I had. Also running 2S because there was no need to run at 3S. This thing was already a speed demon at 2S speeds. So if we have a look in here, it is fairly simplified because the whole point of this, as I said, was to be bulletproof. So the engineering principle, keep it simple, stupid, came in here quite a lot, because you can see all we've really got is the two brushless motors, one on either side, and then a mounting bracket for those, and then this flexible PLA inner, which has a big cut through the middle, which we'll talk about in a second, because we are going to pull all of this apart in just a second. And that's also kind of where the single stage gearing comes in terms of the keeping it simple, because single stage is the easiest thing that we could do outside of a YOLO drive system. The problem with a YOLO drive, and why I didn't go a YOLO drive, because I do have motors powerful enough to do that, is again the forces on the wheel. I didn't want the forces that are going to be on the wheel in a hit going directly through either of these motors. So instead, we put them on a gear train, and actually this is a flexible PLA gear, which was a bad choice in the end because it did end up burning out. But the whole point of this was that if any force was going through this wheel, that the flexible PLA gear would kind of bend a little bit and not transfer that force into the motor, hopefully allowing the motor to survive the hit properly. Mostly because I didn't want to bother sitting down and doing a full design for a brushless hub motor when I had very little time on my hands. So this Yeah, this gearing system was all about keeping this drivetrain as rigid as possible and stopping the force from going anywhere other than through the chassis and then through the wheel and out, essentially. Yeah, okay, so let us pull out the motors by undoing this, and then we can have a look at the actual inner piece. Now, I'll also say we do have some skids on the side. These are just PLA. They were supposed to be HDPE, but I did not have time to cut them in HDPE, so they ended up just being PLA. Their entire purpose was to keep the front wedge mere millimeters off the ground so that I wasn't running on a Hardox surface, because that's kind of a bad idea. And especially with this thing, because pretty much like a ton of the weight is in this 5mm plate. That means you've got a ton of weight forwards off the wheels, and it's trying to run on like metal on wood, which is just going to slow you down and take a lot of the friction away from your wheels. All right, I'm going to pull some stuff out of here. We're going to have a bit more of a look. Okay, so I'm just going to stop pulling things apart to kind of talk a little bit more about some of the stuff that was going on here. So first of all, these are indeed 2826 1200 kV brushless motors, and yeah, literally just a gear on the output shaft on one end of them and then bolted to a mounting plate on the other end. Now internally, they also had a raised section of flexible PLA under here, which was supposed to be a form of shock mounting, so that if there was some force attributed from the wheel into the motor, it would kind of allow it to flex a little bit and everything should be fine. What I didn't account for with that is that this hole is not much bigger than these motors. So if I put this guy back in here, go on. They don't like it, but you can see this hole is not much bigger than this motor. And of course, this is steel and there is tons of magnets in the brushless motor. So it is attracted to the sidewalls of this hole. So I really had to be very, very careful with lining these up when I bolted everything in. And in actual fact, I had Jaden from Raptor Robotics give me a bit of a hand to make sure everything was lined up centrally to these holes when I did that. So in the end, the flexibility in here, while it is a good idea, and shock mounting is a really, really good idea for any kind of battle bot that you want to take massive, massive hits, in this case, it actually runs the motor into the edge of these holes and is a bit of a problem. So the way to fix this is to take a die grinder to these holes and push them out a lot further, allowing the motor more space to wiggle around inside. But I didn't realize that until after I'd put the thing together at the event. So that was that. Yeah, all right, I'm gonna finish taking this apart now. I've decided I'm going to stop at half, because at half I can show you everything I wanted to show you. So this here is part of the flexible PLA inner that comes out of the middle here that holds basically everything in place. So you can see not only does it have the raised section that is the flexibleness for the shock mounting, but it also has heat insert nuts held the right way to have bolts come in from the outside, which is what hold the standoffs in place. It also has a hole through it to allow the brushless motor through, which is actually a bigger hole than the one that's in the side, which is a good idea in general. We also have a hole through, which is the shaft for the drive, and that has a much larger section here where that bolt has to go all the way through this. So it's just another extra little bit of material that the bolt has to go through, which helps line it up and center it in the directions that it needs to be centered. But you might be able to tell by looking at this part, if I can get this to focus up right, this is infill in here, and you're not normally supposed to see infill, and that is very correct. This part I actually had to cut in half with a pair of scissors because it is a very complicated part, and the size of the thing is basically exactly the size it needs to be to sit in here. Unfortunately, that is ignoring the fact that there's a 5mm plate in the way. So this does not fit straight down into the opening, and it can't because otherwise I wouldn't be able to access these holes or that hole. One of those two holes would have to not be in this part, and I couldn't do that. I needed both of those in place. So what I found was that if I cut the thing in half and then placed it in and kind of squished it round and then folded it into place, that way I could get both of the pieces in place. Now it is actually easier when there's not another motor attached in here. When you've got an empty chassis, you can just kind of fold both of the parts in fairly easily. But it was a bit of a problem, as you can see. I don't know that there's an easier way to do this. I think next time I would probably just print it in two halves rather than printing the whole thing and then cutting it down the center line. Yeah, okay, so that's the design considerations for this beast so far. There are some upgrades that I want to make and I want to do to this going forwards. One, of course, is to round out this hole, expand out this hole. One, that's going to drop a little bit of weight off for me, and two, it's going to allow the motors to not touch that, which I think they did a little bit because I think I'm seeing some rubbing marks on some of these motors. Two, I need to upgrade the gear system. So this gear is going to become aluminium, I think. I've got some bits coming for a CNC router that should be able to cut these gears out of aluminium. I hope. They are a complicated part, so we'll see how we go. And then these gears are either going to be HDPE or they're going to stay ABS. I don't quite know right now which one's going to be hardier and stronger. Probably HDPE, but they also have quite a long throat or a long attachment point on them. So I should show you this as well, actually, because how these wheels are constructed is important. So this is how these wheels are constructed. They are an RC car tire, which is just fairly robust in and of itself, with a flexible PLA wheel. So there's a bunch of flex and give in that wheel. And then they are a hex onto our drive system. Now we've got an output hex and then a step-up hex. So this step-up hex is just to get over the lip in the wheel so that the gear doesn't touch the rubber, essentially. But yeah, those are just a very tight hex, actually. It's very, very hard to get them in and out, which is why I wasn't too worried about them, maybe flying off or anything in hits. But because this output hex is quite this long, it's going to make milling all of this stuff harder, I think. I'm not really a milling expert, so I'm not 100% sure if this does make that harder or not, but I have a sneaking suspicion it will. So yeah, that's the inside of that and all of that, and what I think I'm probably going to do with this eventually. Now, the final thing too is I actually had a little bit of weight left. This thing was like 900 grams, so it's still got some weight left in it to make it a full Beetle. So what I'm going to do is I'm going to put some wheel guards, which will be bent HDPE, probably 2 or 3 mil, that go up and out and just protect those wheels a little bit more, and most importantly protect the motors and the gears so that the motor doesn't get hit, because it is technically exposed right now. I mean, the other way we could do that is rather than run the 5mm plate, we run the version with the HDPE front and just put a wider HDPE front on, like I've done with Annie, because yeah, those side juts are there to protect the wheels and bits and pieces like that. So we could just do that, but I do want to run the 5mm thick HD Hardox front on this guy again. So I'll have to look at some HDPE wheel guards or something along those lines. Yeah, okay, well there you go. That has been the breakdown for this scary little beetle. It's yeah, it's an interesting design concept. It was an interesting thing to think about, making something the most robust I could possibly make it, especially considering that I didn't have to worry too much about the weight of weapons and stuff like that. All I needed to worry about was the weight of the chassis, which is actually quite considerable, considering it is all a Hardox chassis. And there you go. You can see here that these two chassis are fairly identical, other than, of course, their front plates. Yeah, I think that's all I've got to say about that. I hope you guys have enjoyed this one. I hope that that's interesting, kind of looking at some of my thought processes and design considerations when building what is essentially a very, very tanky wedge. And yeah, I will see you in the next video.